Okay, here we go. Recording. All right. What do I want to say for intro? All right. Have you ever run more than one test at the same time in the same place and had an unexpected effect? It's something called an interaction effect, and that's what we're going to cover today. Welcome to the Treachery of Data podcast, the companion podcast of the CRO Roundtable, a bite-sized chunk of content summarizing what we discussed last week. Yes, interaction effects. These are, like I said, basically, especially when you're scaling up an experimentation program, like you're wanting, a lot of times you start off like, oh, run one test a month, 2 tests a month, 4 tests, whatever. Like velocity is an important factor in getting value out of an experimentation program, right? Like it's pretty commonly understood. The more tests that you run, the more value you get, right? More swings of the bat, the more chances that you take, right? More pulls on the slot machine, if we're going to use a multi-bandit algorithm. So a common problem then is, okay, if you're scaling up and you want to go from like 4 tests a month to 8 or 10 or 12 or 20, right? At some point, you're going to run into a situation where you're like, all of my different channels are filled up. Like if you're running tests on an e-commerce site, say you have like, oh, we've got a test running on the home page, on the category page, on the product page, on the search results page, like all of your different lanes are full with active tests. Well, so does that all of a sudden mean you're at capacity now and you can't run any more tests? Like you're limited by the number of lanes that you have on a site? Well, no, that's absolutely not true, right? There are plenty of very mature experimentation organizations that run, whatever you see, like bookings, like, oh, we run hundreds of tests a month or something. Like, I'm totally making up numbers. I don't know what they actually do, but right, like you see things like that said pretty regular. Well, how do they get to that place? At some point, you have to start running multiple tests in the same place. And there's a concern there of like, well, if I'm running 2 tests on the product page, what happens? How do I know that the results that I'm seeing isn't the result, isn't happening because of one or the other? Or like, what if both of them are causing things to clash or something? Like one's causing a lift, but the other one's causing a drop, and it's canceling each other out.
So,
and stuff like that.
One thing I would say, just to take a step back, is like to cover off some terminologies.
Oh yeah.
We use. So when you're running multiple experiments, you can there's different ways you can run these multiple experiments. You can overlay them, so have them
right. I'm getting to the point where it's like we can address, okay, here's how to actually do it.
Yeah. So you can overlay them, or you can isolate them. So you can say, like 33% of my traffic on this page are going to see this test, 33 are going to see this test, 33 is going to see this test, etc. Or you can run it as an MVT. So you can have like one test with all of the different combinations built into the test itself. Or you can do them sequentially. So you basically go, I want to run multiple tests on this page. I'll wait for this test to finish and then I'll run the next test. So yeah. And then one thing, you mentioned, is basically, yes. So the overlaying experiments is like what you generally want to do when you want to scale and run lots of tests at the same time. So it's
yeah, those 3 methods. With sequential, that's still your early stage where you're not actually running concurrent experiments within the same place at the same time. You're just queuing up like, oh, we have 5 product page tests that we want to run. We want to run this one and then this one and then this one, right? They're not actually running at the same time concurrently. They're not overlapping from each other, right? Isolated versus MVT, and let's explain what MVT is. But isolated is like, that's another method of doing it where, okay, you can run tests concurrently, but they're still mutually exclusive because you're basically like sectioning your traffic apart. Like, oh, half traffic that comes to the page gets is like only exposed to test A. The other half is only exposed to test B. Like, you're basically like segmenting your traffic. Now, the drawback there is you need a lot of traffic to do something like that, because all of a sudden, if you're cutting the traffic that you're putting into a test in half, that's probably going to like significantly affect your pretest calculations, like your run times and things like that. Okay, so there's a trade-off there of like, sure, we're running tests at the same time, but they have to run longer. So does that actually increase velocity? And then an MVT, that stands for
And also, sorry,
multivariate. Oh, sorry, go ahead.
the complexity of actually keeping those isolated. That's the technical complexity of keeping the tests isolated. That could be an issue as well. Like,
Oh,
how can
yeah.
you guarantee that these people stay in their lanes in terms of like which tests they're being assigned
Especially
to?
if you're running a client-side testing tool, which
Yes.
most people probably are, which means you're relying on like cookies or local storage or something like that. And it's very easy for the user to clear out that data, and then all of a sudden, they're exposed to a different test, right? So there's a huge technical drawback trying to run test isolation. MVT is essentially taking your multiple tests and mushing them all together into a single test instead, where instead of like variation A and variation B, you're creating a matrix of variation. So it's like you have change A and with variation 1 and 2, change B with variation 1 and 2. So your results in like A1, B1, A1, B2, et cetera, right? Like, you're basically like making a two-dimensional matrix of like all of the potential different variation changes you're trying to test concurrent. That way, and then your report gives you like, okay, if for users that saw this combination of variants, here's how they performed, right? So that's a better approach, but again, there's still some complexities there too,
Yeah,
of like,
especially because you need to develop all of the tests together in one lump sum. So all of the tests are kind of tied together. So you can't like, release one test at a time. Everything's got to be bundled up and kind of delivered
yeah.
in one.
It also still has the drawback of sample size and traffic as
Yeah.
well, because even though you're not running things in isolation, you're still slicing traffic up much more finely into all the different variant combinations. So you still have to run the test for probably a longer period of time. Anyway, so really none of these three approaches are an ideal solution for velocity scaling. So what is the actual solution?
I think I think we need to bring in Lucas Vermeer in on this as well because basically I learned a lot from reading his stuff about and what he has said about overlaying experiments. But basically, he kind of signals out or singles out overlaying experiments as being the best of a bad bunch. So basically, of all of the of all of the different options we've spoken about, overlaying experiments by far has the best pros versus cons kind of when you break it down in terms of benefits versus
Now,
cons.
what exactly is overlaying experiment?
So overlaying experiments is when you just stack the experiments on top of each other. So you basically
Just
run an
run them at the same
experiment
time.
and then you just run another experiment on top and you just run another experiment on top. And so users can fall into all of the tests and they would fall into the control group of one, maybe the variation group of another, maybe the control group of another, etc. And the gist of it is that you'll have enough of random sampling of people who are in control, variation, control, variation, control, 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 variation, etc., etc. All these different combinations. So in each group of each test, you should have a decent amount of people who are also in either the control group of another test or the variation group
Hmm.
of another test. So when you're, and then what that does is yes, there's going to be a lot of, there's going to be noise. I'm not going to say a lot of noise. I was going to say a lot of noise, but there's going to be noise. But back to Lucas's point, the world is very noisy. So basically just embrace it. Um, and then that, when you do that, you can, it has the best benefits in terms of length of time that your test is running. So you can, instead of running a test for a really long time, sort of all of the technical constraints that go along with isolated and MVT, it's much simpler. And versus sequential, you basically, you're running a lot more tests at the same time. You'll be able to ramp up velocity of testing.
So the drawback with overlaying experiments shifts the concern from being like a statistical barrier to being a planning and execution barrier. Because the problem is you're still dealing with interaction effects, but instead of trying to mitigate it from like in a technical way, you just mitigate it in a planning way. And you just like think about what are the potential ways that that if you run two tests at the same time, how could they potentially interact with each other? And you're only concerned about what we're going to call extreme interaction effects. Like there will be
So
interaction
yeah,
inherently by running two tests at the same time, right? Like what you said.
yeah.
But
So I think in the
inherent noisiness of data mitigates like basic or non-extreme interaction
yeah,
effects.
in the conversion world roundtable, you mentioned the different types of interactions that could happen. Could you just go over those three
Yeah.
things?
Yeah. So the three ways that tests can interact with themselves are they can either have an amplification effect where, okay, the two tests are feeding off of each other and enhancing, which potentially that could be a beneficial effect of like, oh, this lifts this thing by a little bit, but then this change and this change make a big lift. Like, oh, great, we want to do both of we want to do both of them at the same time. Um, there's no effect where like they're not really interacting at all, so there's not really an issue. And then there's a dampening effect of like, oh, this like, like one thing causes a lift, one other thing causes a lift, but the two things together, they're like fighting against each other or something like that. So really what you want to and this is just like how when you plan single tests, right? Like what is your desirable outcome? Are you testing for superiority or are you testing for non-inferiority? Same thing, like you want to account for the same thing here. You have to think about how could these two potential tests interact with each other, and is that interaction effect not important or desirable? Like if it's an amplification, like okay, then let's go for it. If there's not, then fine. Your only concern is like if there's a dampening effect that's like what's an undesirable outcome, and you want to avoid that. So then, okay, how do you actually plan for that? Like how do you actually like, oh, we have the two tests. How do we think about what the potential outcomes are? So you
Yeah,
do, and we've talked about these before. You do a premortem,
yeah,
and you have to think about like here's all like what are all of the different factors for the tests, and like how to evaluate the potential overlap. So there's three things to consider. There's lane, location, and outcome. Or at least these are the three things that I think about. There might be more, but this is the way that I do it. Lane is your location on the site. You already think about this. Like this is your basic level of like product page, category page, et cetera, et cetera. What's the lane that the test is running in? If there's no lane overlap, then who cares? Run the test at the same time. If there's a little if there's explicit lane overlap, like these tests would have the exact same targeting, okay, that's going to cause overlap. Or is it, maybe there's partial overlap there, like one test only runs on a certain set of product pages that have a feature, like maybe you're testing something about like product attributes or something, and not every product has a selectable attribute, attributes like color or size, things like that, some sort of like option that the user has to specify before they can make the purchase, and maybe only 50% of your products have selectable attributes, and you're actually testing something about the attribute UI. So those product pages are only included in the test. The other half of them aren't. Well, okay, you could also run a test on the other half of those product pages, or you could run a test on like all product pages, and there's only partial overlap there. Location is what is the specific section or module or UI element on the page that's being tested. So, same example, say we're looking at two different product page tests. One of them is maybe trying to affect something in the add to cart section or the call to action area of the product page. Like maybe you're trying to increase add to cart rate. Maybe a different test is trying to affect something related to how the reviews are displayed. Well, those are in two different locations of the page. So maybe it's less likely that they're going to have an interaction effect, because you're trying to actually change and affect two different parts of the page. And the third thing is outcome. What's the primary goal of the test? Do both tests, are they trying to like affect the same goal? Well, then that's going to be much more likely that they're going to have an interaction effect. Like, oh, both of these tests are designed to improve, flow from category page to product page. You're trying to like increase product page views. Well, if they're trying to accomplish the same goal, then they're probably affecting similar things. But if they have different goals, then they're less likely to cause interaction. So like those three things you have to evaluate against, and like, think about it in a range. Like, what's the level of overlap? Is it like one of these things is the same? Are all three of them the same? Et cetera, et cetera. And then what's your appetite?
Yeah, I think one thing you mentioned as well, like I think is a really key point, is is out of the amplifying and out of no effect and dampen. The only one we're really interested in is the damping, and that's the only one that's really an issue. In terms of like the other things, because again, to quote Lucas Vermeer, because he mentions like extreme interaction effects. Because in the way that, because at Trainline, we used to run a lot of experiments overlaid on top of each other. I used to have
you have a lot more practical experience at this than.
Yeah, I guess because the sheer, the number of teams running the experiments on the science stuff. So in terms of like, there was some concern over interaction effects, and in a way, like the key sort of TLDR is interaction effects are okay. They're not an issue. What are an issue are extreme interaction effects. So, and if an extreme interaction effect causes, if an interaction effect has no effect whatsoever, well, basically that's of no interest. It's obviously you're not going to worry about that. If it amplifies, you have a choice. You either can invest in resources to analyze this amplification or this interaction effect. And one of the things I often tell people is like the quickest way to make an analyst cry is to ask them to analyze interaction effects across loads of experiments. Because that will bring them to tears very quickly. It's very expensive in terms of resources to do. So in terms of weighing up the amount of resource that you're going to spend versus just kind of moving quick. So we're like, yep, this was a win, this was a loss, I'm moving on. That is by far the biggest advantage. So in terms of amplifying, I don't see that as an issue because, say it was going to be a loss. It's more of a loss, or it's going to be a win, but it was more of a win. So, you either way, you see the impact in the variation in each test. So then, yeah, it's not an issue. In terms of like a procedure for doing extreme interaction effects and dampening. So I'll give you an example of a test where a dampening effect could happen. Say you've got something, say you're working on a panel and that panel is in the, above the scroll on the page. So now say you've got another test come in that's now moved so that you've got a test one, which is updating the copy of that panel. You've now got a test two, which has now pushed that panel below the fold. So that will have a dampening effect on that test one, which is our test on the panel. So in terms of when it comes to things like this, the procedure I had for the guys, like the product owners, for whoever wanted to run before they launch a test, is to run through a list of things. One, do a technical check. Are they working on the same component as another test? If so, there could be a risk of defects because, from a code-based perspective, you're manipulating the same component. And so for that,
it's into what I called location.
Yeah, that's what you call
looking at the actual HTML structure of the page and being like, this test, both of these tests affect something within this particular HTML container or this area of the visual area of the UI.
Yeah, exactly. And sometimes it might not actually be visually the same. You might not see it visually as the same component, but in the behind the scenes in the code, it is the same component, in which case, it's a shared component that's shared across two things in two different locations. Manipulating that might break something else. So there's that. And then there's also like, just checking for, if your tests are working on the same conversion lever. So I guess that's similar to your lane sort of thing and the outcome. I don't actually think the outcome is like most of the tests that we were running were all conversion led. And so from that perspective, it wasn't such a big issue.
Well, we can dive down a rabbit hole there on how do you define primary KPIs for a test? Like I have a particular method that I use and with that, like in that planning system, that typically allows for more overlap because I'm only factoring in like the user behavior goal in terms of interaction effects. Because like business goal is almost invariably like something bottom of funnel, order conversion rate, or some sort of like metric that's explicitly tied to monetary value at the bottom of the site funnel.
You mean
so,
like
if literally, right, like you're running tests on an e-commerce site, right? The business goal is probably improve revenue in some way. Well, if your KPI for literally every test is improve revenue, then technically every test overlaps and you can only run one at a time.
So I guess you're talking about behavior, what I call behavioral goals. So
yes.
So in terms of like behavioral goals, if you're leveraging the same behavioral goals, then there could be an issue. Not necessarily that there is an issue, but there could be an issue. And also doing a very quick design check, like that instance talked about, like this panel.
Oh, we're trying to affect the same thing, so there could be an issue. So now I have to do a mental exercise on like, what would the potential outcome of the combination of effects be? Like, could these be mutually beneficial? Like, you have to do your like amplified versus deaden evaluation there.
Yeah. And in a lot of cases, it was like, when product owners used to come to me and go, I'm trying to launch this test, but I'm not sure about the interaction effects. And I was like, okay, does it worry you to launch this test now? Yes. Uh, Even though I can't prove that there might be an interaction effect, but I'm a little bit worried to launch at the same time as this other test. Okay, so when does this other test end? Other test ends in a week. Okay, so what's the cost in delaying the test for a week? So that's the kind of like um, uh, kind of procedure to go through. In terms of like going back to the dampening effect, it's the because one of the other things that people mention is like, oh, why didn't you just run it as an MVT then? Run them all at the same time. Actually, for the dampening effect, if there is if the tests are staggered in terms of their releases enough, you should be able to see in the cumulative conversion rate variation versus test report that, hey, something weird happened here where the win is severely dampened. Well, this test was released at that time, and in that case, it could be more than likely when you see that dampening effect, you look at that other test that was released, you will see a negative impact to conversion on that test, and then at that point, you might want to pause that test for a while in order to see whether or not that picks up on the other test. But there's lots of stuff
Yeah.
that you can do on a while the tests are running.
Talking
Um,
about timing, that's a really good point as well. Because more often than not, you're not batch releasing tests, right? You're releasing them on a cascading cadence. You're not like turning on 5 product page tests at the same time. You may have 5 concurrently running, but they're all in different stages of progress.
yeah,
And so, as part of your like weekly or daily or however your monitoring cadence, right? You're like looking at your test results and seeing how things are changing. And it's like, oh, we turned a test on 2 days ago, like, but we saw a marked dip in this metric starting 2 days ago. Now, correlation is not causation, but there's maybe some evidence there of like, oh, this is like we turned this test on and we saw this metric dampen when that happened. So, there's maybe a reason there to investigate.
yeah. And sometimes you might want to, like investigate interaction effects between tests, but I would I would say that that would be a minority of cases rather than trying to measure interaction effects
If
across
something's
all the
interesting enough,
tests.
just follow up on it. Run
Yeah,
another
yeah,
test, or like run like if there's something interesting enough there, just run a multivariate version of it that combines
yeah.
those two effects to validate or verify.
Or just pause it, or just wait a while to see
Yeah,
once you got enough traffic.
yeah.
I often say to people, like, you can either spend a lot of time now, or you can just do nothing and let the volume of data kind of show you what's happening. Unless it's an issue, unless there's an actual defect or an issue or whatever. If you're just curious about something, you basically you might want to just leave the test running for an additional week or so. Because what you want to make sure you have is going back to the beginning where you have, like, in both your control and variation group of every test, you should have a good representation of control and variation of every other test in each of those groups. So in your control group, you'll have a good representation of the other tests, control group and variation group. In the variation group, same again, a good representation of all the different combinations uh, of users in those tests. So, but yeah, but in general, I think people are often, there was of so much debate and talk about interaction effects. Uh, this is why, like, I put out I created the procedure at Trainline, because there's so much talk about it. Like, oh yeah, and this issue and this issue and this issue. Whereas just put it into a procedure and it kind of resolved the whole issue. And actually, in terms of interaction effects, with a few choice decisions for specific tests, you can avoid the whole sort of issue, or it's actually what we discovered is it's actually more overblown as an issue than people think. People
Yeah,
imagine that these interaction effects are having like a huge impact on all of your tests.
that's a really great summary. Is like,
Yeah. Yeah, just to add a summary to this is like, and just like the small text. Um,
mhm.
so every site is different, and every company setup is different. Some companies have more resources than others, etc., etc. More analysis resources, more different kind of technical tools available than others. But and so in general, like interaction effects, just want to say interaction effects can be quite interesting to analyze, and I've seen some interesting results come as a result of that. But it shouldn't, I don't think, uh, slow down your testing. If it's impacting your velocity, then you shouldn't let it impact your velocity unless it's an issue. So yeah, just want to cover that off. There's no one answer, one approach for every site, every company.
That's basically a summary of every CRO thing.
Yeah, yeah, yeah. It depends, I guess, is what to say.
No, that's a different podcast.
Yes, that's a different podcast.
It's is that Paul Randall's?
Is it Paul?
I
Oh,
think.
yeah.
I think. Yeah. Yeah. Shout out to Paul.
Shout out to Paul. Yeah, has a good name for a podcast.
Yeah. All
So
right.
yeah,
Good. Oh,
anything else
anything
you want
else?
to?
I asked first. No.
Ah.
No, I think that covers it pretty well. As always, if you have questions or feedback about today's episode or anything else that we've talked about, you can always see me and Iqbal face to face every week on Fridays at CRO Roundtable. You can join at conversionworld.co. If you're shy or you don't like speaking, you can always hit us up on LinkedIn. And thanks for listening. We will catch you next time.